So you've been at this workflow game for quite a while now, both before Temporal and now. What are some of the most surprising ways you've seen developers use Temporal?
Mm, okay, nothing surprises me really, because it's a very mm, like general purpose platform, right? Practically, it just makes your code robust. Every time you need a guarantee of execution, you will do that. So it's practically used everywhere. It's like you can practically start from like up the stack. For example, at Uber, you need to deploy a new version of a kernel to the data center. How do you do that? You deploy it and then you need to reboot every machine. So coordinated reboot of every machine in your data center, all the hundreds of thousands of machines, obviously it's a workflow using this technology, right? Then you go up the stack, then you need to manage deployments, right? So you need to manage your Kubernetes clusters. You need to manage your infrastructure. For example, HashiCorp, their cloud service is built around this technology because it allows them to coordinate practically deployments and the maintenance of the backend of their, like, I don't know, Nomad clusters and other resources. Datadog uses that to practically do all the backend orchestration. That is kind of another one for kind of this. And there are a lot of companies building control planes. If you need to build control plane for your service, that is one of the best technologies to do that. Then you go up the stack. For example, you want to do application deployments, right? CI/CD pipelines. That Netflix, for example, rebuilt their version of Spinnaker on top of that. And now they decided not to even use Kubernetes at all because it stopped scaling for them, and they just use Temporal directly to practically do all the infrastructure automation. Then you go up the stack and you talk about data pipelines, right? You talk data pipelines, data movement, like everything related to processing data. Because think about most data solutions, they are good crunching files. But the moment you say, oh, when I'm processing this, I need to do a bunch of API calls, which are not reliable, data pipelines, usual data pipelines technologies are not good for that. And for example, like you're doing invoice generation, right? Or you're doing end of months invoice generation. You have a big batch job, but every invoice can be one API call, it can be 10,000 API calls. For example, at Uber, when you had invoices for companies, some companies are huge, right? So invoice can take 1 hour to generate for one company, but it can be small because it's a two-people company. So how do you orchestrate those? So, and then you go up the stack, you things like payments, right? So a lot of banks and companies, like every Coinbase transaction goes for this type of system, right? Because they like need reliability of transferring data between different blockchains. So payments, real-time payments in India, for example, in Brazil, like you know that because UPI in India, right? This type of instant payments, people use it for that. And then like real backend payments, like banks and your orchestrate between each other. And then you use things like customer onboarding, business flows, like, you know, and now AI agents. AI agents is a very powerful use case there that people use it for. So because if you think about it, we focused a lot on frameworks, right? How you could make these calls and how you transform data. But we have so many frameworks right now. Why? Because it's not that hard to write a framework. But the problem is that running this framework at scale resiliently with all the failure modes is actually much harder. And what we are seeing right now that a lot of people who know about Temporal, they directly come to us and say, can you just integrate with all these frameworks and make them run resiliently? So this is what we are looking for to do is that can we just make the existing frameworks and run them on top of Temporal so you get the benefits of all the nice abstractions they're creating. And we make sure that we can run these things at scale and resiliently.
It's really amazing how broad of a use case it has. But durable execution, I think, it's probably one of the more powerful concepts. I mean, even though like it's sort of like it's existed in other forms for a while, it's one of the more powerful concepts that I think has been coined recently. And there's a lot of startups in this space that I think Temporal has like inspired to tackle this problem more broadly. I actually worked at one myself for a little bit, and I wanted to ask you about like a technical problem that we had ran into. So you'd mentioned previously that you're using event sourcing for like capturing essentially like side effects and making sure that those are logged so they don't have to be reran and you can just use old results. One of the challenges with that approach is if you have either really large payloads, you get a really large response back, or if you have like a streaming response, then it can be hard to store those effectively in the logs. So like how does Temporal try to help with these? And I think like the streaming response is like really applicable to maybe AI workflows. I guess they're doing a lot of those.
So there are multiple questions there, right? One is large payloads. There are two really different use cases for large payloads. One is that you just need to pass it through from one activity to another, right? You need to look into that. You just got file, you pass this file to another activity. So usually what you do is you do some level of indirection, right? You put it in some other storage, for example, S3 or some blob store or some even a local file. We actually because we can route tasks to the same host, right? You can practically cache it locally or you're in process. And that is one way to solve that efficiently, just local caching and maybe storing and then only passing pointers around. And we are working on framework level features to make this passing pointers around seamless, like in easy. That is one. Another one, sometimes you want to look at the payload inside of the workflow code. And there are kind of a couple options. One option is that you just, again, cache these things and you return them very fast. And second one is sometimes you don't need the full payload to recover workflow state, because usually imagine you have a function which counts words in the file, right? So and then you say, oh, if I have less than 500 words, take this path, otherwise take other path. The only thing you need to store is the counter, right? Not the whole file. So there are techniques to make that efficient. So you could be able to kind of only store smaller results. And we will provide them as well. For streaming, it's an interesting question. Do you know any use case for streaming in the AI world which doesn't involve human waiting for tokens?
Not really. I mean, it's just used as a sign of progress mostly.
Yeah. So, I'm old enough to remember dial-up. And I remember that I acutely knew how picture every JPEG loaded, right? It could load from the top, it could load interlaced, right? Like it was like the whole thing watching the JPEG loading. So my claim is that we are living in the JPEG like dial-up world of LLMs. And the moment LLMs become fast and produce those tokens faster, the whole streaming will go away because nobody would care about that, because it just will appear instantaneously. And all backend agents, like agents which are actually doing real work on the backend, for example, calling tools and doing other things, they don't need streaming. You need the full result to actually make your next decision. So reality is that workflows don't need streaming. There are some use cases when streaming is useful, and we are going to integrate them. I have ideas how to do that. I probably don't have time to kind of go in details there. But reality is that for all practical reasons, streaming is purely entertainment for the user while it's waiting for your kind of LLM to do the work. And you don't need workflow engine for that. You can just pass the stream directly. You can use Temporal to pass the pointer to the stream to the client efficiently. And then we can support streams natively. You can use something like Redis or some other technology. But I don't think there is a really need for durable execution to support streams for these specific LLM-based use cases.